I am Luca. I work at Microsoft in the Azure organization, and I'm a systemd maintainer.
Yeah, I'm Daan. I work at Meta on systemd stuff. All right, so let's get started. This whole story started, let's say 6-7 months ago at FOSDEM, where I did a talk on ParticleOS, a new distribution designed to make Lennart use his own stuff, right? So that looked something like this. How did things change after FOSDEM? Well, it became this. So, right, I'll just repeat the same slide from FOSDEM. We want to do dogfooding of systemd. And so systemd started as, of course, just an init system. And that is pretty much used on all distributions, right? So Lennart kind of dogfoods that automatically by just installing Fedora, right? But in recent years, systemd has grown like all these amazing tools for image-based operating systems. But distributions weren't like immediately adopting all of these. So the question then was like, who is actually using this stuff before like the actual users that try to use it and hope to not encounter any bugs? And well, the answer to that question was not entirely clear. So this is like the state at when we did FOSDEM is only these things were actually being used on Lennart's laptop, including credentials, I guess. But no, well, I forgot to fix the slide, but it wasn't a lot more than this. What did we have on Luca's laptop at the time? It was already looking a little bit better, but also missing a lot of stuff. And my laptop with ParticleOS had a lot more green than both of the other two did. Did we succeed is then the question, right? Did anything change after FOSDEM aside from Luca joining my crusade against Lennart? And the answer is, actually, yes, right? Lennart's talks today have been on ParticleOS instead of his regular Fedora install.
Woo! So one thing we want to talk about is that this is a talk about dogfooding, and buying into the whole ParticleOS is not necessary to do dogfooding for system components. As I mentioned in the previous talk, or 2 talks ago, we are now building packages that contain the latest content of systemd built from Git main automatically on each merge and push. So we use the SUSE build system for this, Open Build Service, and they graciously provide a public instance that any open source developer can use, and we are very thankful for them. I'm especially thankful to Adrian Schroeter, who helps me up and keep all the distribution configuration working when I annoy him on IRC. So we publish packages for x86, ARM64, for Fedora, Arch, Debian, Ubuntu, and SUSE. Now, when upstream projects provide packages, very often, not always, but very often, the quality and setup are really not the same as the distro ones, and that creates problems when you want to upgrade or downgrade because the packaging structure is not the same and whatnot. For this project, however, we took we made the decision to actually use the recipes from the respective distribution. So we literally pull from Git, from the same branches that Ubuntu or SUSE or Fedora use to build their packages, and we just use the content from Git main. Of course, we enable new components if there are, we install new files because we do things in main, but otherwise the packaging structure, the number of packages, the names, the relationships, the maintainer scripts, it's all the same as your normal distribution. That means these are very safe to use in terms of being able to upgrade and downgrade and giving you the same experience as your distro package would. Now, of course, this is Git main, so it usually works. Usually, sometimes it doesn't. So don't go run your hospitals with these packages or your local bank. But if you are a developer, a hacker, a power user, these are very much good for you to use. And I think most people in this audience will fit right at home with this if you use a traditional distribution with packages instead of an image-based one. So we do encourage people to try and use this to help us find regressions. And we find a few more as we continue. So, with all this dogfooding, are we actually finding problems? And the answer is, of course we are. So someone, and we are still all trying to find the person who did this, someone last week broke the combination of the new nspawn and old machined. And it crashed horribly when you had that, for example, doing a package upgrade. And thanks to dogfooding, having these packages on my laptop, I was able to find it immediately and fix it. And we're still looking for the person who did that. So previously, there was also a login D regression. So at some point, some new features were added to login D, and the problem there is that we have we have no tests for graphical environments because we don't build GUIs, we don't build desktops, we build a system component. Our integration test suite has absolutely nothing for GNOME. So at some point, logging in GNOME didn't work. So I woke up on a Monday morning, turned on my work laptop, and instead of the GNOME greeter, I was met by a black screen, which was great fun, especially trying to bisect and downgrade on a TTY on my laptop to figure out what went wrong where. But that's dogfooding, right? So by me finding this on my laptop, users didn't do that when we released. Other things we found, so there's approximately, Lennart in one of the great blog post series or on Mastodon talked about the netboot use case when you have a net DSP. Also, basically, you only have a systemd boot and a configuration for it, and you boot that, and the configuration points to a URL, so it downloads the UKI, and then the UKI downloads the DDI and flashes that to the disk. So you basically boot a full system based on starting from systemd boot and a config file. Great idea, fantastic, love it. Does it work? Yeah, it works for you. There's a few issues there that I'm trying to collate there and trying to make them work. So again, that's all part of the dogfooding story. And something else that happened, again, as part of this, someone read about ParticleOS. I don't know if you saw that.
Yes.
And said, yeah, let's try that. I have a machine with 2 disks, my main disk and then a spare one. I can just try ParticleOS on the spare disk and leave the normal one with my normal distribution. Of course, installing ParticleOS immediately blasted away the wrong disk. So this person was left with an unbootable machine. Sorry, user on Mastodon, if you did that. Thank you for your service in dogfooding systemd. Another thing I found out, just talked about before, if you just have UKIs and sysupdate, but without an image-based rootfs, I could not be able to find a way to make sysupdate keep the UKI that was running on your system as it upgrades. And so if you configure to keep 3 UKIs as it upgrades, the new version come along, you should always keep the currently running one, right? Because new ones, you don't know if they work. So what happened is that it didn't do that. At some point, I was, again, left with an unbootable machine because his update blasted away the running UKI from the ESP. I didn't have it anymore. I had 2 new UKIs, neither of which worked. So my machine was also, again, I had to fetch another UKI and build it locally. Again, these are things that are hard to test for. I forgot to mention it about the machined one. Matteo added some upgrade-downgrade tests, but it's very hard to do, so we have minimal coverage for PID1. We're trying to expand that, but we don't have very good tests for that either, and this is a common theme. Our regression test can test a lot of things, but not everything, and we have lots of gaps, and this is what it helps with. And yes, we do find bugs.
And we do not find bugs just in systemd. We also find bugs in UEFI firmware. So this is the only one, but also a very major one that we found out. It turns out, because UKIs in systemd start, especially when you start doing stuff like ParticleOS, start adding profiles, UKI profiles, and other stuff, you end up with a lot more PE sections in your PE binaries than is usual, or than maybe even ever happened before in a general Linux system setup with EFI. And so I painfully figured out that once you go above 24, the AMI firmware, certain AMI firmware versions just say, nope, you cannot boot this anymore. So that was a fun one to bisect, but eventually figured it out, and I think the bug even got fixed.
Yes, so thanks to my colleagues at Microsoft in the UFI group, they contacted the AMI firmware developer and said, oh yeah, we have a limit of 25 sections. Why? Do you need more? And they obviously never heard of UKIs before. So yes, we asked them to please fix it and remove this limit, and I believe new AMI firmwares will have this limit removed. But yeah, old ones, yeah, sorry. Buy new machine.
Or yeah, I'm currently running ParticleOS with like, I don't know, most of the profiles just deleted from my local checkout, just so I can get a working system. I was planning on doing a lot more work on ParticleOS since FOSDEM, and well, life happened, so I didn't have time to do that, but luckily Lennart did it for me. So let's take a look at what Lennart did over the past few months, specifically for ParticleOS. The first things that got added are the root equals dissect and the mount.user equals dissect options. These are kernel command line options to basically have systemd figure out your or dissect your root disk based on the image dissection logic we already have in systemd. So we already use this for image dissection in nspawn, in PID1, root image, all these things. Already use this dissection logic, but we didn't yet use it for the dissection that's happening when booting up the system. And though this basically exposed that, and this allows a bunch of nice things. For example, GPT Auto Generator can now set up DM-Verity protected root and user partitions on its own. Previously, this was like a combination of GPT Auto Generator doing some stuff and then F-step generator doing something else, but only if you specified user hash or root hash on the command line. So the entire thing was very limited, and I regularly had users in macOS side that tried to do something that was outside of the golden path, so to say. They wanted to do Verity without putting a root hash on the kernel command line, and it never worked. It was always hard to debug, and this fixes more or less all of that. It also allows applying image policies to the root disk properly, so you can define a image policy as implemented by Lennart, which allows you to say we will only mount, like, I don't know, root and a home partition, or for example from this disk image, and we ignore all other partitions, or the root partition has to be encrypted and we won't look at anything else, or it has to be Verity protected and we will ignore it otherwise. All that stuff can be specified with the image policies, and because we now have these two options, it will all apply to the root disk. Factory reset got reworked. So this came out of Lennart trying out ParticleOS and then thinking this needs to have factory reset, right? It was one of the 5 points in his talk this morning, like undo. So he tried to add factory reset. He noticed it did not work in the slightest, and so he fixed it. And this, to me, this is like a great win. The issue specifically with factory reset is that it did not play nice with GPT Auto Generator. GPT Auto Generator, or what was it? Factory reset was not waiting for GPT Auto Generator. So basically, both things happened at the same time, instead of everything else in the initRD waiting until the factory reset had completed before continuing. And this is now fixed and properly documented and everything in the upstream repository. Systemd Homed got a bunch of features to allow sharing homes between different systems. So while I was hoping at FOSDEM to get Lennart to completely switch to ParticleOS and never look back, reality turned out to be not quite that. So Lennart has been dual booting ParticleOS and his old Fedora install, and of course he needed a way to share his home directory between his old Fedora install and ParticleOS. And before FOSDEM, Homed only had local key signing, so you had your local key and all your homes were signed with that, and then sharing across different machines wasn't really it was possible, but was not really nice or implemented in a user-friendly way. So he added all of that so that he could easily share his systemd home between his old install and his new install. And then systemd first boot and homekernel first boot. I can talk about it here, but I think it will be much better when we show it in Luca's demo lately. But basically, we get a tab completion now. So this seems super simple, but when you're getting into the systemd first boot wizard and you need to select your time zone, it's very nice to have auto completion for it. Seems like a small thing, but very useful. Chrome, so yeah, it's not Google Chrome. You'll see what it is. It's absolutely amazing, but you'll see. And then we have systemd crypt setup first boot is something we still need. So when you install ParticleOS, you get the whole first systemd first boot and then home kernel first boot to set up your user, set up a systemd home for it, and etc. But we do not yet have a wizard, a simple wizard to set up a recovery key for your encrypted root partition. And this is something that we really need. So that's still something we're waiting for, but we'll get that eventually. So currently, if my TPM setup on my laptop goes wrong and it doesn't like the PCRs anymore, then I lose everything. But luckily, I don't have too much important stuff on there. And so these are more or less temporary solutions for now, because what we're really hoping is, of course, for GNOME and for KDE, their initial setup tools, to integrate with all of the systemd stuff, so that you, instead of having to go through a TTY wizard, you get a nice fancy UI where you can do all of the same stuff, but with a much better user experience. The latest upcoming, but I don't have too much to tell about it because I still need to review the PR, is systemd sysinstall. So this is a combination of systemd repart, bootctl, and for now kernel install. But I don't know if I want to let that pass through. But we'll see that we'll see that later. But it wants to combine all the steps required to install systemd from a USB stick, basically, to the final disk target. Currently, you have to run a arcane systemd repart command to do the actual copy from the USB to the final disk. But the goal is to also make that a nice wizard, so that you boot into the installer UKI profile and you get a nice wizard. You get to select the disk you want to install the image to, and then it does everything for you. You get a nice progress bar and everything. So this is coming soon, but the PR for that just got put up, but I'm pretty sure it'll be in 2.5.9. Actually, it will definitely be in 2.5.9.
We have a month and a half.
Yes. Systemd repart improvements. So this is you.
You want to do the first one?
Oh, yes. This is a very simple thing. When you were using, systemd repart has this feature copy blocks equals auto, which allows it to basically transparently copy the current system to another disk image. So you can, this is for example, very useful for the live USB, which has ParticleOS, to copy it to another disk. And this is using the copy blocks auto feature, but this didn't yet work for Verity signature partitions. Of course, we do need to do those to get copied as well. And the reason was that all the other partitions, like the Verity hash partition and the actual user partition and such, can be traced back via mount points, but the Verity sig partition could not be. And so what Lennart did is he added a bunch of metadata in UDEV that allows you to trace back the mounted partitions to also figure out the Verity signature one and copy it over as well. So small thing, very useful.
Yeah, so when you are hacking on things and doing your own builds, then it's obviously fine to do inline signing. You run repart, and then it asks for your password, for your key, YubiKey, or whatever else you use to store your private key, and then you do the signing and continue. For the next topic, we're going to introduce remote builds to have a bit more production-oriented way of building the systems. But there were some missing features there, and that's what we have added there since the last for instance, is FOSDEM. So basically, in many of these production systems, you don't do these inline builds because they are offline, they are segregated, the code being built is untrusted, and you don't want that to have any access whatsoever to the machine, container, whatever that has your private keys material. So you do offline bit signing. First, you build your artifacts, and then your build stops, and then you send some form of the artifacts hash sums in whatever it might be, depending on the build system. You send it away, and then you get it back with the signatures, and you restart a build, or you do a separate build step. But basically, you don't have control over the signing step. You produce hashes, you get back signatures, and then it's up to you to reassemble them. This is how usually these systems work. That's true for both things inside Microsoft and things like the SUSE Open Build Service. So we've added support for doing exactly this. So you can do a systemd repart signing, and it produces, building, produces the Verity images, but it leaves the space for the signature, but doesn't fill it, and then produces a root hash, and then you can come back and do a second systemd repart step, where it just attaches the signature that you give to it to the partition that it created before. So your steps are build DDI without signature, take hash, take signatures back, then rerun, repart, and attach a signature. Same thing for UKIFI, for the PCR SIG. So if you have been following all the TPM features, a UKI has some PCR SIG sections that contain the signed, let me get this right. The signed values of the PCRs are they expected to be when you boot and launch that machine. Is nodding, so I got this right. Excellent. But that means you have to do multiple steps here. First, you prepare your UKI, and then you know what's in there, and then you prepare these measurements, and then you reattach them, and then you have the UKI, but then you also need to sign the UKI. So this is a three-step build. First, you produce your UKI, and then you give it the hashes, the signed PCR SIGs, and then you give it the final P signature that envelops the whole UKI. So UKIFI and systemd measure supports this workflow now, and pretty sure there was one else that I can't remember. But yeah, we have this. Of course, we also have inline signing is still there with engine and provider support. And this, introduces us to the topic of remote builds. Again, as I just mentioned, if you are a hacker, that's so great. You do your own builds on your laptop and put it on another laptop or a NAC or things like that. But if you are not a developer, that's really asking random users, oh yeah, go ahead and run this bunch of scripts and things and build your own images on your own machine and do your own private key management and do that securely, otherwise you're screwed. It's a bit of a tall order. So for a generic, any generic distribution doesn't do that, doesn't tell you, yeah, build your own image starting from packages. They give you live media that you can just flash and install, and it's ready and it's good to go. So the idea is, how can we make this happen with ParticleOS? We need a build system that gives us several features that we need. First of all, we need to support mkUSI because that is the tool that we use. Then we want, we live in 2020s, not in the 90s, so we want automated rebuilds when there are updates. If the kernel changes, I don't want to have to manually say, okay, now rebuild my ParticleOS image. The system should figure it out by itself and publish a new image. We want to support multiple distros. Like normally, if you try to run the Fedora build system for images, it builds Fedora images because that's for Fedora, so obviously that's what it does. But we want to support multiple ones. We want to support multiple architectures, at least ARM and x86. We want to have multiple image formats. We have the DDI format that we want to support. Very few other distributions support that. They usually publish ISOs. We want to support secure signing, meaning you don't have to manage your own private keys. The system does it for you. And ideally, the publisher doesn't even control the keys. I set up a project to be ParticleOS. I don't want to be in control of those keys. I want the system to control them for me. Of course, we need customizations. And finally, we don't want to be telling users, oh yeah, write your own code to write a pipeline on GitHub to do your builds there. We want this to be configuration-driven, not code-driven. So in my view, the Open Build Service by SUSE is the perfect use case for this. They graciously make available a public instance that everybody can use. What are the key features of this? It's not a CI system. It's a distribution build system. So packages and images are the first-class concept. GitHub CI it doesn't have a concept of packages or anything. It's a pipeline stage. We want here packages and images to be the first-class concept. You give it sources as source packages or recipes as input, and then it figures out the dependencies, and then it gives you out assigned images or packages. I set up some builds that we will see in a moment. I don't have control over the signing key for this. Even if I wanted to, I cannot access them. These are hidden somewhere in an HSM inside the SUSE data center, and it's the same processes that they use for their enterprise and their SUSE distributions. So you can put the same trust in the signing that I do for these ParticleOS images as you do for any other SUSE images. I cannot take the key and sign something else that you can't see. Of course, it did not support mkUSI when I started, so me and a few other people work on that, but now it's there. And yeah, we can build and sign and publish either a very simple UKI with an inline configuration, or a more complex project like ParticleOS from Git. And so you can have, again, a configuration there just for the UKI and mkrosconf. I will show them in a moment, or a full project from Git. And that almost worked with a few hacks that I'm waiting for Daan to fix, but we still have a couple of hacks there for the full thing. But now let's see if I can actually show some pages from that. At least I had it ready. Right, so if we go on, for example, this is the page. I hope it is visible. Zoom in a bit. So this is how it looks like. We do system colon systemd is our namespace, and we have a ParticleOS for Debian. And the way OBS works is that if you want to fetch from Git, you define a service file. And you can see this just points to our ParticleOS repository. Again, a special branch because we need some hacks there, but otherwise, that's just our GitHub repo. And then it builds some results out there. One is fetching some updates for Debian testing. For Debian 13, it's already built. So if we go here, we will see the results. This is for developers, right? It's for developers, people doing their own builds. They will see this image, these pages. If you're a user, you just see the download repo. So in the download repo, you see here some standalone UKIs. I'll show them in a moment. And otherwise, all the ParticleOS things. Let's see if I can manage. This is very hard to do on the other screen. There we go. We can see all the ParticleOS stuff. So we have both version, the latest version, and also unversion symlinks. So if you point your downloader to ParticleOS.raw, it will always point to the last version, this one here. So as Thorsten showed before, we also publish manifests. The manifests are signed for those who do all this nice SBOM stuff. And yeah, there's the partition there so that sysupdate can work and so on and so forth. If we go back, I mentioned the standalone UKI. So that is a complex project. So ParticleOS has many config files. So you have a Git repository to store them. But if you have a simple configuration, like you want to just build a UKI, you can have an inline mkrosconf. You just add it here, and then you write it there, just a mkrosconf file. The only special thing is that you need to include these mkrosconf OBS resource, I think we call them, and that set up all the sign-in stuff for you, so you don't have to, and automatically does all of that. And then it's just a UKI. You say, for my UKI, you want a manifest in JSON, yeah, image ID and output is standard UK mkrosconf things, and then whatever packages you want in your NRT. If you want to customize it to remove stuff, I do that. And kernel modules, kernel command line. So this is, again, just mkrosconf. I am running this image on this laptop. And I've been running this UKI built here, built on your OBS, and downloaded by sysupdate for a few months now. And again, apart of a few hiccups I mentioned before, this has worked quite nicely, I would say. So yeah, that is how it looks. A few more words about that. Going back to the presentation. Excellent. Yeah, so it's the two links at the bottom there. Anybody who wants to use them just goes to the download repository that is linked there and can just point their sysupdate to any of those images, only the UKI or the full ParticleOS. And yeah, everything works for some value of work. Now, how is this set up? In terms of, especially the security story. So in terms of secure boot, these images are set up to self-enroll on first boot for your secure boot databases. So the OBS project key that is for the systemd namespace will be enrolled together with the Microsoft CAC and DB key. These are very much necessary for op-ROMs. Like, do not self-enroll on a actual hardware without the Microsoft keys, because you will break your hardware. Someone on the systemd channel did that some time ago. They had to solder something to the motherboard to try and recover it. So always have the Microsoft keys, because of option ROMs. Your hardware might need signed option ROMs. Otherwise, those keys are there. So then the sysupdate keys are there and are published. And for sysupdate, so that it automatically does updates. UKI is assigned, tpn-do stuff is there, sign manifest is there for all the SBOM stuff, DDIs, of course, it's signed, and we publish GNOME flavor for Debian 13 testing, Fedora 42 rawhide, and with flat tab enabled. So let's now quickly switch to our demo. If I can find my mouse pointer. OK. So So of course, this is recorded because I'm not crazy. So this, which I have downloaded this from OBS, the download is low, so I'm not going to show it. Of course, if it starts, that will be good. Good, exactly so. This shows just installing ParticleOS on a VM. So we do VM spawn, growing the disk with some gigabytes and so on. You saw some nice green, that is the tinting stuff. Now the ParticleOS comes with multiple profiles. We talk about UKI profiles, that's what it was. Now we pick the main profile and we boot it. Then bam, we got tinting again. And that's VM spawn, tints your background green. What this does is immediately installs ParticleOS on the disk that it was booted from. You can see there, the repart has run, and now, bam, Chrome. This is the Chroming stuff. When he added it, I didn't notice, so I did this demo, and I was like, what the hell is this? I wasn't aware of these banners, but Lennart added this. Very nice. It should be systemd green instead of blue, but it looks very nice. So that's the first boot that Daan talked about. So we just added some user test, very secure password, as you can see there, very long, definitely use that again. One thing I've been arguing about is, well, on first boot, we don't have any. Even in the GNOME flavor, it's not enabled, so you don't get any GUI. So you have to do this. You have to enable GDM, and then shut down, and then start again. And we've been debating whether this should be the default or not, but for now it isn't. So we start again.
The reason was that the GDM would interrupt the first boot stuff, and the home kernel first boot stuff. So as soon as like GNOME does all the stuff in GNOME initial setup, then we will just enable GDM and whatever by default.
Excellent. So, Adrian, get on with it. Right. So now we are rebooting in GDB. Sorry, in GNOME. Let me push forward a little. Too much. OK. So I want to show the update flow here. Of course, we're running run 0. And I want to show the SUSE update. So this is, again, an OBS built image. It comes with empty partitions for your AB. You can see it installed swap, home, root, and home on the fly, encrypted with a TPM. You can see there, TPM2 enrolled. It has HOMD, of course. And now it is configured for SUSE update to pull new images from OBS. We can check, and there's a new one. We can show the old one that was 22.1, and then we can just say update CTL. Now, this is going to be very slow because of the download time, so I'm going to skip ahead. Now, GNOME will get in the next version support for SUSE updates, so you will be able to do this from...
I put his hand up. I think we have a problem.
What?
It already has it, even better.
Oh, right. But it's not enabled by default, right?
Yeah, it's off after compile time by default.
We should get on by default, yes. Sorry, folks. Let me try zoom again. All right. Too much. I wanted to show a dogfooding bug. This looks terrible. I'm sorry. There we go. So, no, he went. So I wanted to show a dogfooding bug. Basically, the first time you install an update with a new UKI and you reboot, systemd boot picks the wrong version as the default one. So there we go. So it picked the live. It went away again, but it selected the live profile as a default, and you shouldn't do that. So basically, the first time I tried this, I rebooted, and I was in a live profile, nothing worked. I was like, what the fuck? And systemd boot. I think it's a combination of boot counting and the profiling and the sort key that don't quite work together. So another hopefully future dogfooding win. Yes, I think we are done now, and we can go back to the slides. Here, there we go. We have some more questions, but I think we are out of time. So let's go back to York.
Well, thank you for this wonderful talk.
Thank you.
And does anybody have questions?
Would you recommend that anybody in this room who isn't Lennart use this as their primary OS?
Yes. If you're a developer or a hacker, for your machine, definitely go for it. Not on your production system. Don't run your local hospital with this. But on your machines, yes. You can pick and choose. Again, I'm running UKIs and packages on this laptop. It's my work laptop. It's the only one I have.
But don't expect it all to work out of all the time, and be prepared to file bugs if something doesn't work.
Yes.
Eventually, we'll get more stable versions of this, I guess. But for now, it's all running on extremely recent versions of systemd or git main, because we are implementing a lot of features to make this work. So we're, by necessity, running off git main for most of the time.
This might be a dumb question, but if anything goes wrong, I can roll back to my...
Well, I did
purchase
get
them.
at least 2 user reports that the rolling back isn't working at the moment. So,
So yes, try that and report bugs then.
So I use ParticleOS to build a small custom OS for an arcade machine. And one thing I've noticed that is challenging is tracking regressions, meaning that things will work and then
They don't.
a few months later, I'll be like, oh, I should update this. And I pin the macOSI and ParticleOS repository because I'm not crazy. And then nothing works anymore. And I was wondering if you thought about what could be done to kind of test regressions or make sure that when you update things don't regress, and likewise, somebody that actually uses this for a production deployment could do to test this without having to set up something like OpenQA, because that seems kind of
Yes,
overkill.
that was going to be my answer. Give me infinite money, and then we can set up OpenQA. OBS has hooks for OpenQA, so you can publish images into OpenQA. They are tested and then published only if that's good.
Oh.
Give me infinite money, and we do that.
Okay.
It's a bit but I don't know if you have other...
the other take on this is that I want to get to a state where you can pin absolutely everything that is involved in the build, so that you can pin the distribution, pin systemd, pin macOSI, and that allows you to, one, choose which when you upgrade. It's not like when you rebuild this 3 months later that you suddenly get a bunch of new packages from the distribution and then something goes wrong and you cannot bisect it. If you are able to pin everything to a timestamp or a git commit or something, then that allows you to bisect things more easily because you have like a starting point and end point, and you can simply go between them to figure out where things broke. I think that will help in doing the bisecting yourself if you want to do that. But of course, a test suite to make sure it never even breaks in the first place is probably better.
Yeah.
Yeah, if you want to have all this testing, I mean, you could try to make this a deliverable of OpenSUSE Tumbleweed. I mean, Tumbleweed already produces various live images, various formats, not just ISOs, but also live images, flavors for GNOME, for KDE, for XFCE. They produces microOS in different flavors, and this microOS desktop, it could also produce ParticleOS, and then it would send that through OpenQA. You would even get a staging project, and if you talk to the guys, they will probably set up a staging project just for you. So yeah, you could get it for free somehow.
I guess the question there would be if the integration, you know, to do the booting and the configuration and so on is compatible between, like the first boot is probably not compatible, so maybe the test will need some update, but it's a good idea, thank you.
Well, then I guess we're out of time and out of questions. So let's thank both of them again. And
thank you.